So does anybody have any particular questions from the homework? Here, let me do something here. So these are the questions. If you weren't able to attempt some of them, if you just want to pick some, that's fine with me too. Just type them in chat, or I can just pick a few at random. Eight to 10, yeah, I agree. So just to show you, these N and O are the two questions that I was referring to. I think I did this one with everybody yesterday, where it was all odd numbers. And I realized, I can't remember who it was that suggested integers is the correct, what the heck am I trying to say here? The numerical group. But yeah, I guess negative numbers are fine, because negative odd numbers would just flip the fraction and still give us -1. So yeah, that group would have been fine, I think, for that. Same thing for this one here. This one would just be all even numbers. So those are the two that I was referring to yesterday. So here are some of those fractional ones. Again, just to remind you a little bit of what we were doing yesterday. You just flip them, make the power negative, and then find the correct base. Here's some examples of the questions that have negative signs in front of the number, not inside the bracket. Okay, so I was trying to give you a smattering of all the different kinds here for these ones. So if I can just move on, I will, because I would rather spend more time on the more difficult questions. We didn't do 11 yet. We'll get back to that. So the suggestion was anything from 8 to 10. Let me just quickly skim through 7 here and make sure. Yeah, I feel like those should be pretty doable. Do you have, for number 8, is there a specific one looking at those that you would like me to do? Okay, well let's just do F. I mean, usually the last one in the grouping is one of the more difficult ones. It looks like E and F are kind of similar. So if I do F from number 8, that should be good enough. Okay, so here's where I have to juggle multiple screens here, so give me a second to figure this out. Okay, I'm trying to see chat at the same time as I see the question and at the same time as I see the smartboard, and I think everything's good. Okay, so 8F. So 8F says 16 to the 3 plus k is equal to 32 to the 1 minus 2k. Sorry, it's really small on my screen here. I'm just going to make it a little bit bigger so I can see it better. Okay, so looking at all of the questions in number 8, this is an exercise in do you know how to find the base as fast as possible, right? This one's not so bad. And you probably have noticed that a lot of the bases are going to be 2s or 3s or 4s. Sometimes 5s, because 125 is a pretty easy one to figure out as well. But the book won't go much higher than that because it's just really big numbers and the math is all still the same. So, so here, I think everybody can see that we would use a base of 2. Yeah, so power for 16. sorry, the base of 2's power or exponent that gives 16 is 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. And then, well, luckily 32 is one more 2 bigger than that, so that would be 2 to the power of 5. And now that our bases are the same, we just have to work with our powers, and we're going to skip the step where we rewrite the bases again. We're just going to go directly to the distributivity here. Okay, so 4 times 3 is 12. 4 times k is 4k. 5 times 1 is 5. 5 times negative 2k is minus 10k. And now I want to rearrange everything to get my k's on the left-hand side, because this is a negative 10, so it'll be a positive 14 over here when it joins with that 4. And it'll be 5 minus 12, which I think is negative 7. And we then divide by 14, which also reduces to negative 1/2. So, you know, there's multiple steps here, but I'm hoping that everybody's okay with those steps. You know, finding the bases probably is the hardest part. The rest is just regular algebra. So, are we good to continue? So, I'm not sure if you have your textbooks in front of you here, folks. It'll be a lot faster if I don't have to keep switching back and forth from the textbook slide to the smartboard slide. So it looks like everybody's okay with that example. So let's just move on to another example. But I'm just gonna, unless you have a textbook open and want to call out a number, I'm just gonna pick a few of them. Okay. So let's take a look at one of them from number 9 now. So I'm going to choose to do, I'm going to warm us up a little bit. Let's do C to start. So 9 to the y over 5 is equal to 27. So I'll try to fix this up a little bit here, sorry. Okay, so I think this is the first time I didn't show an example of a scenario where you have an exponent that's a fraction, but it's done the same way. So the first thing we would do is get our bases the same. Oops, I didn't leave myself enough room there. Yes, bases of 3. So this will be a 3 to the 2 to turn the 9 into a 3 to the 2. And the y over 5 is still going to be here. 27 is 3 to the 3. 3 times 3 is 9. 9 times 3 is 27. So now my bases are the same. Technically, I don't need the bracket there, but whatever. So now we just combine these two. So this is still a power of a power, which requires a multiplication. So you just have to remember how to multiply a fraction times a number, which a lot of people tend to forget is top times top, bottom times bottom. So the bottom number under the 2 here is a 1. 2 over 1 is the integer, so 2 times y, correct. And we just make it equal. Now, because these two numbers are the same, I'm just going to highlight, and you know, this is the 3 that's here. Okay, it's not the base of the 3, the base of the exponent. So now we're just solving this regular linear equation here. The 5 that's dividing, we usually get rid of fractions before we do anything else, if we have the chance. And then y is equal to 15 over 2. Okay, so not much more difficult, a little bit, you know, strange to see maybe, but it's not that much more difficult. I'll wait to see if there's any questions, and then we'll move on to 9F. Okay, doesn't look like there's any questions. If you're, if you ever want to ask questions outside of the stream, please just email me. You can take a snapshot of that. So it's 3 over 2 to the m over 2 equals 4 over 9. So we just need to find a common base. Can we do that here? Yes, we can. So a little tricky here. I don't know if anybody sees what we have to do. Can you see how we can change this into this base? That's right. This is flipped. We can't turn 3 into 4, but we can turn 3 into 9. So we're going to have to flip this thing upside down. So I'm going to show you all the steps in order, just so that I don't lose anybody. There's already some discussion in chat as to what the correct way of doing it is. So if I flip this upside down, I have to put a -1 out here, right? So, so now that 3 will be related to the 9, and the 2 will be related to the 4 by a power of 2. So again, I'm going to show all of the steps separately here. Okay. Now, not to spend too much time writing every step, I'm just going to go over to the side here. 3 to the 2 over 2 to the 2 can actually just be written as 3 over 2 all squared, like that. Okay, because the way an outer power works is it affects everything inside the bracket, both the top and the bottom of the fraction. So, so this combined with the -1, we can think of as this combined with the -1. So we will get 3 over 2 to the m over 2 equals 3 over 2 to the -2. And yeah, that was the correct suggestion looking back in chat. So good job there. Okay, so now we can just drop the bases. So 3 over 2, oh, sorry, not write the bases. So m over 2 is equal to -2, and then m is equal to -4 by multiplying both sides by 2. So I think I did that all right. I can't show the entire question here, but I'm pretty sure that's correct. So a little bit misleading at the beginning, looking like the 3 can't turn into a 4, but you have to be a little bit more aware of the fact that we can flip those fractions, and then everything works out. Okay. Yeah, no, discuss and chat all you want. Just be nice to each other. Wait. Do I have to wait for something? Okay. All right. So that was question 9F. Probably the more difficult one in number 9. Let's move on to question number 10. So again, I don't think I showed any examples of this. I like to give you some challenges in the homework that go a little bit beyond the lesson. You do have the skills to be able to solve. We're just going to start with 10A. You do have the skills to solve this. And the issue here is we now have a number multiplying the exponential. So, what do you do? right? You can't combine a base of 3 with a base of 5, so we can't group these two together, which potentially could happen later. But there's no way of grouping these two together, okay? So that 3 is causing us a problem. We've got to get rid of that 3. Well, that's simple. How do we get rid of a multiplication? We just divide, right? So that 3 is going to go over there through a division, right? So we're going to have 5 to the x plus 1 equals, and I'll write it the long way just so you see exactly what's going on. Which would give us 5 to the x plus 1 equals 5. So when you have, and I mean, these questions are designed to work, right? And to be a little bit challenging. And I can't show you every possible case, but anytime you have a number alone in front of the exponential that doesn't have an x, because if it had an x in here, then we'd be in trouble, okay? If we had an x as a power, that would be probably a logarithm scenario. But because it's not, there's no power here, we can just bring it over to the other side, get rid of it, and then solve it the same way as before. So now, I hope everybody sees that this power is going to be a 1 here. Please don't mistake it to be a 0, okay? So x plus 1 is equal to 1. And, oh, well, the final answer ends up being 0 here, which is okay. That does happen sometimes. And if we look back up here, if I put a 0, you know, if we wanted to check our answer, if I put a 0 here, 5 to the 0 plus 1 would be 5 to the 1. 5 to the 1 is just 5. 3 times 5 is equal to 15. So that does make sense. Okay, so the only thing weird about question 10, and I'm going to do another one from question 10. I'm going to do F because F is a little bit tricky. Well, not necessarily, but there's a couple of ways you can do F. But anyway, is that number in front. So let's look at F, and let's discuss the different ways that we could solve F. So this is what question F looks like. So there are two ways of proceeding here. The way we would proceed if we followed the example of A above is keep that on that side, bring the 27 on this side. Right, divide by 27, right? And then we just do exactly the same thing as we did above. Now, 3 over 27 reduces to 1 over 9. And 9 is 1 over 3 squared. So you can easily get the same base. You'd have to flip it, right? But there's something interesting about this one. Isn't 27 3 to the power of 3, right? So just to give you an option here, I'm not sure if you've already seen this or even considered it. My gosh, there's a lot of 3's in that question. Anyway, so these two are the same base now. So this is a different scenario than the one up here. This one had two different bases, so we couldn't combine them. However, and I know we didn't review the exponent laws, but there is a law that allows you to combine two bases that are the same. If you're multiplying a to the m times a to the n, what do we do with the two exponents? Yeah, you could just add those two exponents. So you can actually combine these two things by just adding the two exponents. So you would have 3 to the 3x plus 1 plus 3 that came from here equals 3. And this becomes, now see how the bases are the same here? We could just drop the bases now, and if I combine this together, we'd have 3x plus 4 equals, now the power on this side is a 1. So we'd have to write our 1 there, and then we could solve the equation. And what's nice about this method is I didn't have to flip and use negative exponents, which shouldn't be a problem anyway. But those two should give the same answer. Okay, so because I noticed that 27 could be written as a base of 3, and knowing that my exponent laws allows me to combine bases that are the same, then that's the way that would work. Okay, so that's question number 10. I did the first one and the last one. That should be more than enough if you're struggling with that at all. I'm going to pause here for a second. Are there any other questions between 7, 8, 9, 10? Looking at the homework, let me bring up that page again. Does anybody want me to solve anything else from that section? I got one no. Okay, I am going to assume then that that's enough help for those questions. We'll come back to 11 later. I also had asked you as a challenge to come and look at number 19. So I would maybe like to look at a couple of those. Now you'll notice in number 20, I probably should have assigned a few of them from number 20 as well. Those are all of those quadratic, not the hard quadratic. These are easier quadratic ones where you just make the powers the same, equal to each other, and then isolate on one side, make it equal to 0, and find your zeros. Okay, so we could potentially, and maybe I'll give those in well, actually there's some coming in an assignment later anyway, so it doesn't really matter. But these ones here, number 19, they look a little bit more intimidating. So let's take a look at a couple of those. And I'm going to transition back to my smart notebook here. Okay. Oh, I'm going to need, before I get to that. Okay. So, I'm going to do number 19a, where we have 27 to the x over 9 to the 2x minus 1 equals 3 to the x plus 4. So the question we actually just did before this one is going to help us kind of understand how to do these kinds of questions. What happens is the bases can be combined together. Okay, so all of these are bases of 3. So 27 is 3 to the 3 to the x. 9 is 3 to the 2 to the 2x minus 1. And then we have our 3 to the x plus 4 on this side. So here, I'm just going to simplify our powers a little bit. So we have 3 to the 3x over 3 to the 4x minus 2. And then 3 to the x plus 4 on this side. So what happens here is we have a division of bases that are the same. Well, just like before, there's a rule for that. And it's just subtract the exponents. Okay? So we're just going to subtract those exponents. And again, I'm going to drop the bases at this point. So we have 3x minus 4x minus 2. And I'm going to write it this way. And the reason I'm writing it this way is because if you try to do it in your head, both of these are being subtracted, which means the negative in front of the 2 is going to switch to a positive. So we're going to have 3x minus 4x plus 2 is equal to x plus 4. 3x minus 4x is negative 1x. Plus 2 equals x plus 4. And then if I bring, I'd want to bring this negative 1x over to this side to join that x to get a positive x value. So we'd have 2x. Going to bring the plus 4 over to this side, becomes a minus 4, so minus 2. And then x equals negative 1 is our final answer. So even though this one might have looked intimidating at the beginning, if you start to understand that, once we find our bases that are the same, sometimes you can actually combine them even though they're dividing or multiplying, because there's rules for that, okay? Then everything kind of falls into place at that point. Are there any questions about that one? And I feel with that example that the rest of number 19 should be solvable if you didn't try them. So I'm going to stop there for the homework correction. And this is where the actual lesson for today is going to start then. We're going to look at the questions that were similar to, I think it was example 3 that I asked you to look at yesterday, if you wanted to. So how do you solve questions like this, which is basically the last, or one of the last kinds that we need to look at. So there's a big difference between this question and the one where we used variable substitution yesterday. And the difference is here. Yesterday, this was a 2x, and now it's an x plus 2. All right? Now, when it's a 2x, you could write it as a power of 2, like a quadratic. But you can't do that here. You have to try to remember, and we actually just saw the rule, what would have made two exponents add together? Well, that would be if we actually had this scenario. Okay, 2 to the x times 2 to the 2. You add the powers. So that's not the same thing as this from yesterday. Okay, this means it's a power of 2, which is a quadratic. There is a power of 2 here, but it's not next to the x. So this is not technically a quadratic. What you can do in a situation like this, as example 3 shows, is you can factor. You can factor that 2 to the x out of both of those, which has already been mentioned in chat. So if I factor the 2 to the x out, what do I have left? I have 2 to the 2, which is 4, minus 1 equals 48. So 2 to the 2 gave me the 4 that was left over from this one, and 2 to the x factored out here gives me a 1. So that, now the proper way of writing this would be 3 times 2 to the x equals 48. Okay, I know the 3 is second here, but usually we write coefficients in front of things with variables in them. Okay, and then we divide by 3. and I'm going to let you finish that one off. Okay? Somebody's already, I think, given the answer in the in chat. So the hard part is realizing when you have a subtraction like yesterday, there's usually some sort of tricky thing going on, or an addition, frankly. And being able to break this power up into the actual two things that made that power appear, in this case, did not give what we saw yesterday. It gives a new situation where you're allowed to factor the 2 to the x's. So that one's a little bit more challenging. There are more examples to try. I'll get to that in a minute. I am going to continue here if that's okay with everybody. So I did want to finish with just one more example similar to yesterday's and to compare and contrast the one that we just did. So can you see the difference here between this one? And I know this one has multiple subtractions and additions, okay? But the main difference is right here. This is a 2x, not an x plus 2. And that's what makes this a little bit different than the one before. So if we rewrite this as a quadratic, it would look like this. So again, the biggest difference is right here. This is now a power of 2. So I'm going to use my variable substitution method from yesterday. We're going to call that big X. We're going to call that big X. Okay, so we get that expression. And that is now factorable as a quadratic. I hope it is anyway. So it'd be 3 and -1. So that means we get just going to break that off to the side there. So we get our big X here, our big X here, and because this is a type 1 trinomial, we just take the two numbers from our product and sum, put them right in there. Isolate for X to get our zeros. Like so. I'm going to pause there for a second. Take a look at each line. We did an example like this yesterday. Are there any questions about how the 5 to the 2x becomes this, or the variable substitution? So we're not done yet. The reason I kept writing the x's in green is because now we have to redo the variable substitution to get back to our 5 to the x. So there are our two answers. Sorry, not our answers, but our two resubstituted values. So as we saw yesterday, this one doesn't work. You can't have a positive base become a negative number, so we just eliminate that one completely. What is the only answer here that makes sense? What is the only power that will change any base to a 1? And that is x equals 0. So I have had some students get confused here. It's like, well, how do I turn 1 into a 5? Well, you can. It's 5 to the 0. But anything to the 0 equals 1. So this is a tricky one, more or less. It sometimes throws people off. But anytime an exponential scenario is equal to 1, it's just x equals 0 usually. Oops. And if I'm not mistaken, that today might be a bit of a shorter lesson, just because that's kind of all I wanted to do. Not being able to get you to go on Zoom and actually do some of these, which would have actually taken a lot longer. But I'm trying to figure out a way of making this a little bit more interactive, folks. So that's why I was kind of hoping to maybe try out Zoom. But usually this lesson, or after this lesson, I would be giving a handout that has a whole bunch of questions. I am going to post that handout on the Google Classroom. Now, it has a lot of questions on it, but the way I've done it in the past is I would give every student a selected amount of questions to do. So everybody wouldn't be working on exactly the same questions, but they'd be working on questions that are very similar. You know how I like to do that, okay? Clearly, the more practice you get, the better you're going to be. But so what I'm going to do is I'm going to post that handout, and I'm going to give you a list of questions that I'd like you to do, with the idea that if you struggle with any of them, to either ask somebody else for help or ask me for help through email, and try more of the kinds of questions that are causing you problems. So this is the assignment I'm talking about, okay? If you look at it, it's very long. But I normally just give like students like 1 or 2 of them to do in one of them to do in 2, et cetera, et cetera. And I give a list of those as a separate piece of paper. So I think I'm going to do the same thing, but everybody's going to get the same piece of paper, okay? Everybody's going to be working on the same questions. If you're in contact with each other outside of this stream, then you can help each other out. But if you are struggling with any section, this will give you a lot of examples to be able to practice with. So that's going to be the end of the lesson today. At the moment, folks, I'm not planning on having a lesson tomorrow, because normally this would have been tomorrow. Today or tomorrow would have been a work. I will post it on the classroom stream. So you don't have to worry. I will post this on the classroom stream. But one of these 2 days would have been a work period. So I'm going to give you that tomorrow. Okay, this is going to be a work period to try to solve the questions on this handout. Yeah, that's going to be it for today, folks. And again, tomorrow there's no video lesson, but there is an assignment that's going to be given. Okay, I'm going to say bye. And we'll talk soon.